Okay. All right, so today we are doing matrix multiplication. Okay. It's a little trickier than what we did yesterday. Yesterday when we had addition or subtraction, if we were adding together C and D, we take the entry here for C11 and D11, and we add those together. You find your new entry in your new C plus D matrix, right? So that was yesterday. Who felt pretty good about that? Pretty straightforward, right? It's just corresponding, 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 corresponding. The only difference today is when we multiply, this is one of those instances where it has slightly different properties than we're used to. For instance, when we have A times B, usually, right, the commutative property, A times B, 2 times 3 is equal to 3 times 2, right? And that's something that we kind of have from, properties of equality. But with a matrix, with matrices, matrix A times B isn't equal to matrix B times A. We're going to see why that works out. The other main thing that's different is, the other key here is the number of columns in the first matrix has to equal the number of rows in the second matrix. So instead of doing, entry and then entry, when we're adding it, entry, then entry, the corresponding entries, here we're actually going to be multiplying the terms that are in the columns from matrix 1. We're going to multiply it to the rows in matrix 2. So those have to line up. They have to have the same number of columns in number 1, and rows in number 2 have to be equal. Okay, so it's just a little bit different. I think you'll see when we do this. We'll do this with patterns here. So first off, I want you to look at all these matrices up here, and who could tell me 2 matrices that we're going to be able to multiply together? Look at the first key element up here. Think about that for a second. So which 2 matrices will we be able to multiply together? There's a couple options that maybe are more obvious, but see if you can find a few options here. Okay, who has one they could throw out there? Which ones can we multiply? What do you say? So again, the number of columns in the first matrix has to equal the number of rows in the second. Yeah. A and E. Okay. So you're saying the columns in first matrix. So there's 1, 2, 3 columns. And how many rows do we have in matrix in E? 1, 2, 3. So we could multiply those together. Okay. Anyone else have another one? There's 2 that are probably a little more obvious. Yeah. C and F. Okay. Because we have a 2 by 2, 2 by 2. Those have the same number of rows and columns. You could also do what? C and D, right? Give me an example that won't work. What example won't work here? C, say again? C and A, okay. So here we have the columns. We have 1, 2, 3, right? Rows, we have 1, 2. Same thing. Well, actually, look at this. If it is A times C, right? That doesn't work because A has 1, 2, 3, C has 2 rows, right? But how about, well, let's just double check. How about C times A? C has how many columns? 1, 2, right? A has how many rows? 1, 2. So actually, you can't do A times C, but you could do C times A. You see how it actually has to work out that way. And that's part of why multiplying matrices is a little bit tricky. And that is the area we're going to go into. So just know that it is always relating the columns in matrix 1 with the rows in matrix 2. Okay? And A times B doesn't necessarily equal B times A. One may be possible, one may not be possible. Okay? So I think it's a good start. We're going to go slowly through this. I want you to look at that sheet that I handed out. And the top bit here, where it says the multiplying matrices, the top row I think is a little less helpful to see what process we're going to deal with. The top just says, we're going to multiply row 1 of A times column 1 of B. Now there's another function that's involved in that. And I want you to look down on example I. Example 1, I, is C times A.
Now, if we look at that, and if we look at that closely, we have the first entry here. The first entry is 1 times 2 plus 2 times 1. Now, where do those values come from? If we look up, we have our C. Our C matrix is 1, 3, 2, 4. And we have our A matrix is 2, 1, negative 1, 4, 3, 5. Okay. So how did we get our first entry in our new matrix, that is C times A? How do we get 1 times 2 and then we add it to 2 times 1? Where do those come from? What do we see? This is where it gets a little bit tricky. This is like the main step. So if you have a little zoning out going on, zone back in right here. Because what we end up with is this 1 and 2 come from this row. This 2 and then the 1 come from this column. So what we do is we multiply our entry C11 times A11, but then we multiply C12 by A21. So it multiplies each entry. So first we're going to do the row and the column, multiplying them together. 1 and 2, and then 2 and 1. We add them together. So we'll do this for the next one. Let's look at the next bit here. We end up with, let me do this in black. We end up with 1 times negative 1 plus 2 times 4. Okay. So I want you to look at that for a second, looking at the paper and the two matrices that they came from, two matrices. What is going on here where I have 1 times the negative 1, then a 2 times the 4? How did I end up with that? I want you to think about it first on your own, and then share that pattern with your neighbor. So go ahead, think about it on your own for a few seconds, then double check with your neighbor. If you're not sure, just check right away, maybe figure it out together. So how does that happen? Go ahead and talk to the neighbor.
The only thing I can think of is that it's like this first one and then the second column. There's two.
All right. All right, can anybody explain what pattern we're seeing? Do you see any pattern? It's all random. Not random. Who has an idea and can share it with the class? Yeah, Renaud.
The first row of C is multiplied by each column of A.
Excellent. So you see here, what's happening here is we still have this 1 and the 2 involved, and we're going to see when we get to the next entry here. 1 and 2 come from row 1 of C. Right? We had 1 and 2, 1 and 2. The numbers that are multiplied with them come from matrix A, and they are from the second column. You see how methodically we're working through this. What do you think is going to be here? I'm going to tell you right off. It's going to be 1 and 2 from row 1 of C. And it's going to be multiplied by, what do you think? What column in row A, matrix A do you think? 3 and 5, right? The next column. So you basically say, well, I'm going to start by doing the first matrix is C. I'm going to take that row, and those entries are going to be multiplied one at a time by column, column, and then column. Okay. So if we're going to look here and see that, we end up with 1 times 3 plus 2 times 5. This row for C is always going to be, in our new matrix, it's going to be the entries for the new matrix in row 1 are going to come from that. And then when we get to this next row, that's going to be lined up here. And again, it's going to be the same thing. Row 1 is a part of all the entries of row within CA. Row 2 of CA is going to be from the entries from C, the row, and the columns for each of those. We have to do it a few times. I know that first time through it's tricky. Starting to see the pattern? All right. So let's look here. Next, we're going to have 3. That's from here, 3. We're also going to have 4. We're going to multiply it by some entry. I'm going to do this out, maybe this will help. We're going to have the next entry here, 3 times some entry, plus 4 times some entry. Then we're going to have 3 some entry plus 4 some entry. You see how the second row of our new matrix uses the row from our first matrix down here, row 2 from matrix C. 3 times something plus 4 times something, 3 times something, 4 times something. And now help me out here. Maybe this is the key right here if you can pull all it together from this. What is going to go in our first entry of CA here in row 2? CA 2, 1, right here. What's going to go in these?
2, 1.
2 and 1, what?
Why?
Yeah, what?
It's the first column.
First column of the second matrix. I know it's a lot of language.
Yeah.
I'm somewhat stumbling a little bit too. So we'll just keep using the same language. All right, somebody else help me out. What is going to go for our second entry here? Row 2, column 2 for CA. What are going to go in here? Where do you get them from? What do you say? -1, 4, right? -1, 4. Lastly, 3, 5. So there's a few ways to look at it. You can see that the first matrix, row 1 is going to be encompassed in the top row of our new matrix, and row 2 is going to be in the second. Okay. And then what you're doing is just adding the values of those columns in. So if I was more concise with this, I probably would have set this up before I started. Well, we'll have another example. In the next example, I'll give you another way to organize that info. Okay. So altogether, CA is going to be equal to 2 times 1 times 2 is 2 plus 2 times 1 is 2. 2 plus 2 is 4. 1 and -1 multiply is -1. 2 and 4 is 8. -1 plus 8 is 7. 1 times this is 3 plus 10, 13. Right? See how it's going? 6 plus 4, 10. -3 plus 16, 15. 9 plus 20, 29.
Wait, the paper says 13.
Which one?
Instead of
For 15, it's 13.
14. Oh, that's right. Thank you. Right? Okay. So once you get it all set up, and next option, I'll show you like a little bit better way to set it up. But going from here to here isn't so bad. Okay. It's just that weird. It's doing the rows and columns. So we're going to set it up. I'm going to do an easier one that's just 2 by 2 up here. Let's go ahead. This example isn't on your paper. So first off, we're going to find CD from this right here. So maybe this is where you want to copy down matrix C, matrix D. Go ahead and get those there. And then we're going to figure out CD. Now, when I'm setting this up, here's my new and improved way of setting this up. C and D on this paper. Right? So it's not on your paper, excuse me. It's up here on the board, C and D. So maybe copy those down real quick. And then really what I know here is, this is how I would set it up. I know that row 1 of C is going to be encompassed in our new CD. It's going to be in the row 1 up here. Row 2 is going to be down here. So watch what I'm going to do. 1 times something plus 2 times something. 1 plus.
1 times some entry plus 2 times some entry. You see how I set that up pretty straightforward, right? I put the row from my first matrix set up like so. 2 different entries in row 1 of CD. And on the bottom, the way I'll set it up is -4 times an entry plus 9 times an entry. -4 times some entry plus 9 times some entry. That's actually much cleaner. That would be the easiest way to set it up. Okay. So I had all those entries from C, that's my first matrix. I didn't even check, but yeah, the number of columns in the first matrix, 1, 2, equals the number of rows in the second, 1, 2. So we're good to go with that. All right, somebody help me out. What should I put for these entries here for CD11? What should they? So what goes in here? 11 and 0. I'm entering the values from column 1 of my B matrix here. Next, what's going to go for my second entry? This would be CD1, 2. Row 1, column 2. What goes here? Five what? Someone say 5? It's too new. Nobody wants to take a chance. It's okay. We're going to put that second one in there, the second column. Okay. After you do it a bunch of times, you'll start to see the pattern. Jason? Yeah. Something wrong?
Is it supposed to be multiplying the 2 together?
That's correct. That's what's denoted here. 2, and then the parenthesis is 2 times what's in the parenthesis. Are you looking at the top, very top? So again, look at an example on example 1. It breaks down a little clearer. What?
Oh, wait, never mind.
Got it? Yeah, and it's going to happen. With matrices, you're going to get to where you're like, I know how to do it. And then you're going to come to a step and you're going to have to look back at the notes. So just double check yourself. We're going to do about 2 more of these. I think it'll come together. Next, we had the row from C already set up for row of CD, row 2 here. So what should I put in? What should I put in here? 11 and 0. That's going to be 5, -2. Who could see another pattern, another trend happening? You could have even set this up in a different way by putting what in there first. Who can see a different trend? Yeah, Lance.
The columns for the second matrix.
Excellent. So multiplying C and D, you can also see that the entries for the second matrix are the same in each of our entries in column 1, each of the entries in column 2, and those come from column 1 and column 2 of our D matrix. So that's another way to look at it. I kind of start with the first one, but you can double check yourself. After you get in there, you can see that the rows match, the entries for the rows match, and the entries for the column match from the second matrix. So it's rows and columns are multiplied. Okay. So let's see. Once you have all this in, you just got to keep it organized. And now we can work it all out. These are nice because 0 times anything is 0, so we get 11. 5 plus -4, 1. This is going to be 0 again, so we get -44. This is going to be -18 and -20, -38. You have a note?
Yes.
Great. Okay, thumbs up, sideways down. Is it starting to kind of go this way? It's going in the right direction, though. Okay. We're going to do another one. Actually, we're going to knock out 2 more because I think this next one will be a lot quicker. So, who needs this up here still?
I'll keep it up for a second. Let's go ahead and do columns, rows. I want to do this one. Oh, that's it. Let's do ED. First off, can we do ED? Double check with your neighbor. Can we do ED? ED? ED, not DE. Yeah. We look at ED. We know that the first matrix, the columns have to equal the number of rows in the second. ED has 2 columns. D has 2 rows. So we know that those match. Okay. So there's let's see, how should we set this up then? What do you think? All right. Who has first step? This gets, yeah, that works. 1, 2. So we are taking the rows. Okay. We're going to put them in there like so. So 0 and 1. We're going to have 0. This is going to end up being a 3 by 2. So we go 0 and 1, 0 and 1. 1 and 0. 1, 0. Zero and 3. 0 and 3. So I take my first matrix, I set up the new one, and bringing the rows of E over into ED, setting it all up. The dimensions of the first matrix are always going to be the product of the new matrix. Not always.
So if we were to write the dimensions of both the two matrices, we take one from the side and one from the side. So like 3 by 2 times 2 by 1 is 3 by 1.
Okay. Back to you. Right. Okay. So the number of columns we're setting up is based on the number of columns in the second matrix that are multiplying. That's a key point right there. So you know that the rows are going to be based off your first matrix, E. 1, 2, 3, there's going to be 1, 2, 3. The number of columns are going to be based on the columns in your second matrix you're multiplying. So if I go in here, remember the pattern we saw before. D is my second matrix, so I'm taking my columns, and where should I input my values from my columns now? Right in there. Right. So I go in and I take 11 and 0. 11, 0. 11, 0. Then I'm going to go back in, make sure that for the second column, those are inputted 5, negative 2. 5, negative 2. 5, negative 2. Okay. So first go in, set up the rows. Look to see how many columns you're going to need based on the second matrix, how many columns are in that one. You input them in. And we can go ahead and put the answer over here, ED. Yeah, 0. Negative 2, right? 0 times 11. Negative 2, let's see, we have 11. I love it when zeros are in there. 5, 0, negative 6. So once you get it all set up, It's just multiply that, get each new entry right off the bat. Okay. All right. Are we starting to get a little bit more thumbs up? Getting a little more? Okay, good. So there's one other thing I have to show you, and it's called the identity property. It's nice when the identity property works out. Just looking at A through F, which one doesn't belong? Which one's the kind of oddball up here? Or it looks different, at least. Which one do you think? Which one? E. E is different. E is different. And actually, that's a pretty good guess. F is the one that's a little bit odd because it only has zeros and ones. And we're going to learn that identity matrices, when you multiply them together, you get the same thing. Whatever you're multiplying, we'll stop with that. One sec. Whenever you have an identity matrices and you're multiplying it to another matrix, you end up with the same thing. It's basically like multiplying by 1. Okay. So what I'm going to suggest here is we're going to multiply. We're going to multiply CF. And what I'm going to propose to you is this right here is the identity matrix right here. Identity matrices always have the same number of rows and columns. They're always squares. Always squares. So you can have 2 by 2, 3 by 3, 4 by 4. And when we multiply it, what we're going to try to see is CF equal to 1C. So a scalar of 1. The identity property means, if you have 8, you multiply by 1, you get 8. If you have x squared, you multiply by 1, you get x squared. So we're going to just see now, we need this for something coming up the next couple days, but our identity matrix works out really nice. We're going to see how it works. So let's see. We're seeing if that's true. CF. First off, looking at C and F, it's 2 by 2, 2 by 2, so we know we can multiply them together. So I'm going to go ahead and look at C, and I'm going to take C, and I'm going to put my rows right in that new matrix CF. So it's going to go here. I'm going to have 1 times something plus 2 times something, 1 times something, 2 times something. Okay. So go ahead and fill out what is CF row 2 going to look like? Right here. What's going to go right here? CF row 2. So I filled it in. Basically what I did was take the row from C, set them up with those 2 entries there. Take this row 2 from C, set it up here. And then I go in, and the next bit is I need to go here for our identity matrix 1, 1, 0, 0, 1 here. And I'm just going to input those there. 1, 0, 1, 0, 0, 1. See, so again, there's a symmetry here where column 1 of our new matrix takes those entries from column 1 of our matrix F. All right, let's see what happens. We're going to test this out to see if this is true now. One times 1 plus 2 times 0, 1. Here we have 1 times 0, 0. 2 times 1, 2. 9 times 0, 0, so this ends up being negative 4. Negative 4 times 0, 0. 9 times 1, 9. Okay. What did we just discover? If you multiply anything by the identity matrix, what do you get? You get the same thing. See what I mean? Because we look here, matrix C, it's equivalent to CF. just because matrix F was that identity matrix. You see how that kind of works together? It's kind of nice how that works. This is going to come into play tomorrow and possibly Thursday if we extend matrix into Thursday. I wanted to spread it out a little bit because just today is a lot to get your head around. So that is almost the end of the period because of the projects. You have more homework than usual. It's A through J. It is on your worksheet there. It's also on Edmodo. So how do we feel now about today? We can do this at home, right? Thumbs up, sideways, down. Pretty good. All right, right on, guys. Good job.